All right, guys, today we're just talking about inequalities. Primarily, if we kind of go through this, we're going to start with simple inequalities, move to compound inequalities. How do we solve for inequalities that are linear? And then the last thing we'll cover is how to solve them if we're actually using absolute value inequalities, which is going to be very similar to how we solve normal absolute values. But let's go all the way back to the beginning and talk about writing simple inequalities. So we're going to notice we're given graphs. We have to write our set notation, then we have to write our interval notation just to be able to describe what's happening on this graph rather than having to redo this graph if someone asks it. So if we look at number 1, simple inequalities basically just go one direction. If we kind of look at the difference between these two, that 1, 2, and 3 are all simple. I know you might say 3 goes in two directions, but it's one line. If we look down at 4, 5, 6, and 7, these are going to be called compound inequalities because we do have to write one inequality that covers that and one inequality that covers that one. So I can see two inequalities being combined into one. But let's go back to simple inequalities. So we notice this one, we just have a black line. Now let's talk about a little bit of differences with the dots. So I know something happens at 3. Well, that's a closed dot. That's a closed dot, so this graph is actually including the number 3. So if I want to write in set notation, I want to say it's every number that's 3 and bigger. We're going to go ahead and we're going to use x's to denote our mysterious number. And we'll say, well, x needs to be bigger than or equal to 3. That's all numbers that are bigger than or equal to 3. That's what that x stands for. For interval notation, you always start at the smaller of the numbers. So we start at 3. 3 is our smallest number, so we're going to put a 3. We're going to put a comma. We're going to put infinity. And we're going to put a parenthesis. Now let's just pause here and look at the notation that I used. Well, once again, interval notation starts at your lowest number and goes to your highest number. Our highest number happens to be infinity. So that's our highest, and that's our lowest. I'm also going to notice my choice of a bracket or parenthesis. I start with a bracket because a bracket stands for includes. A parenthesis, on the other hand, stands for it does not include. Does not include. When we say infinity, we don't actually have a number to go to, so we don't include where it ends because we don't actually know where it ended. If this would have ended at 4 and included 4, I would end with a bracket. So we can begin with a parenthesis or a bracket. We can end with a parenthesis or a bracket. And that's what we're going to look at for our next one. We're going to notice that we now have another simple inequality. I just want to be able to tell the person, hey, it's everything that's less than -6. But notice this open dot here. That means do not include. Do not include. So I don't want to include that point in my answer. So we're going to notice that, well, x is going to be small. So I want x to be small, and I want it to be less than 6. Notice the difference between these two. I don't have an equal sign below it because I don't want to include 6. The one above it, I want to include the 3, so I put an equal sign below it. Now when we do our lowest to highest, our lowest is actually going to be -infinity. That's the lowest point I can get to. We're going to go -infinity until I get to 6, but I don't want to go any bigger than 6. So my lowest is -infinity, and 6 is going to be my biggest. Well, we never include negatives or infinities, so I'll put a parenthesis there. And I also said I don't want to include 6, so instead of a bracket, we're going to use a parenthesis for 6. Our last one, notice, is one heavy color. It goes all the way to the left, all the way to the right. This is going to be all real numbers, or all solutions would work for this. To give that interval notation, the lowest number I can get to is -infinity. The biggest number I can go to is +infinity. Once again, we're going to use parentheses for our infinities. Now, our next one, we do have compound inequalities. Like I was saying before, I need an inequality for this section. And I also need an inequality for that section. So if we look at that first blue thing that I circled basically all of the numbers that are less than +1. Note that I do not want to include 1. I'm also going to note I do not want to include 5. So we're going to be using a lot of parentheses. So the lowest point that this graph goes to, it goes all the way to the left, which means that we're going to include negative infinity. Ooh. Let's actually do our x values first before we do interval notation. So x values, I do want to include everything that's less than 1. So we're going to say, okay, I want all the numbers where x is less than 1. But I also want to include all the values where x is bigger than 5. So I also need to say x needs to be bigger than 5. And to join these, we're just going to put an or statement that I can say x can be less than 1 or x can be bigger than 5. Keep this in mind when we go to number 6. Number 6 is similar, but we're going to have to do something else to it. So just keep that in the back of your mind. But right now we can use an or statement because we're going in opposite directions. That's the key. Opposite directions means we're going to use an or statement. The or statement, when we're writing it as interval notation, is going to look like this. I'm going to include all of the numbers from negative infinity until 1, not including 1. Now we need to lift up our pencil and we need to go to our next thing, and that's going to be from 5 to infinity because we're including all those numbers that are 5 and bigger. Now to join these two, we will not use an or statement. Well, we are using an or statement. Technically, we're going to put a little U that stands for union. Union symbol is the same thing as or. Union means or. It means connect those two statements. It says it can be this and it can be 5 to infinity. So it's going to union those two things together. And I should have used the word or because union really is the word or. You can be there or you can be in that 5 to infinity. You can be in either one of those. So our union sign is going to be our or statement. Our next one, we're going to notice it goes in both directions, so it's going to look a lot like the one above, except this time they want where x is less than, it looks like we have a negative 7, or x can be bigger than or equal to 2, because we do have that closed dot, so we're going to use our equal to sign, which means we're going to worry about brackets when we're doing our answers over here. So starting off, going to look the same. We have negative infinity to negative 7, both parentheses. We're going to use our union, which is our or statement. And then we're going to use a bracket for 2 to infinity. That 2 says include it, so we're going to put a bracket there. Now we're going to move to our and statements, that it has to be between these two numbers. So it has to be between negative 4 and 0. So to do that, we're going to write what's called an and statement. So we're going to say x falls between two numbers. So I'm going to put x in the middle. I'm going to say x needs to be bigger than 4. So we're going to put 4 in the bottom and say x needs to be bigger than that. But x also needs to be smaller than 0. So if we're dealing with these that are between two numbers, these are really called and statements. It has to be between negative 4 and 0. It can't be 2, 3, 4, 5, 6. It has to be between those two statements. So writing our interval notation is actually a little bit easier. We just have to say where's the smallest number. Well, our smallest number is negative 4. Where's our biggest number? Well, that's 0. It doesn't include either of those, so I'm going to use parentheses for both. Our next one looks like an and statement as well because we're between two numbers. We're between, looks like we're between negative 1 and 8. So we're going to say negative 1 is my smallest number, 8 is my biggest number, and x is somewhere between there. So now we can start filling our less than and greater than signs. And we just have to make sure we put an equal sign for this negative 1 because that is a closed dot. So when we're filling our interval notation, I should use a bracket negative 1 all the way to 8 parentheses. So be clear of when you're using equal signs, when you're using brackets, when you're using parentheses, are all determined by our dots. And moving forward, we're going to go kind of that opposite direction. So we're going to go from like interval and set notation to making our graphs. And that's what our first thing says. It says solve the graph and write each solution in both set and interval notation. So I need to write it in set and interval notation, and I do also need to graph it. So we have to do 3 things to give this answer. Well, solving an inequality is just like solving an equality, except for one small difference, and we'll get to that in a second. So if this had just a normal equal to sign on it, I would first distribute this negative 3 to both of those. That would give me a negative 12x. We're going to have a positive 6 minus 4x is less than negative 90. Now we're going to combine like terms. So I'm looking at this, what is this? This is negative 12x. I'm looking at this negative 4x, which will give me a negative 16x plus 6 is less than or not or equal to, but it's just less than negative 90. Let's move the 6 to the other side by subtracting it. That's going to give me negative 16x is less than a negative 96. Now I said this is just like solving a linear equation except for one case. And this is that case. So if we move to the left-hand side, I do have a big box here that says, watch out. When you multiply or divide by a negative number, just when you multiply or divide by that negative number, you are going to flip the inequality. So we are going to flip the inequality. Which means if you have a greater than, it's going to flip to a less than. If you have a less than, it's going to flip to a greater than. So let's go back to that problem and note that we are dividing by a negative 16. So we are dividing by that negative 16. That's a problem. When we divide by a negative 16, we can't leave this as is. We need to flip that sign. So rather than being a less than, we're going to have x is greater than negative 16 divided by a negative 96 divided by a negative 16 is going to give us a positive 6. But notice I did flip that sign. That's critical. I flipped that sign to turn into a greater than sign. So now we have x is greater than 6. The nice thing is we already have one of our answers. Here's our set notation. Now I need to put it into, now at this stage you could graph it. You could graph it because sometimes it's easier to go from the graph to the interval notation, but I'm going to go straight to my interval notation. I'm going to say, okay, x needs to be bigger than 6. That means my smallest number must be 6 and my biggest number must be infinity, and both have parentheses on it because there's no equal to sign. Now we're going to go ahead and do our graph. I always give everyone two options. I do like to write above the graph. So a lot of times I'll put that open dot at 6 there, and I'll put it over there so I don't have to shade in heavily. You could likewise put it on the graph. Just make sure you're shading in the right direction so that you can convey to whoever's reading this that you are going in that direction. And you got to shade it in heavily so you can see it. That's why to get away from that, I usually put it above, but you can do either one. Either put it above or you can go ahead and you can put it underneath. Just make sure you're heavily shading in so I know what direction you are going. Our next one, similar type problem. We have a less than, we have 7x plus 23. Once again, I'm going to distribute that negative 5 to both, making sure I change my signs. So I'm going to have a positive 10x. We're going to have a positive 35. We're going to have less than or equal to. So I'm looking at that less than or equal to. That's going to create brackets. That's going to create closed dots. All right, and then we have 7x plus 23. You know I like to create positive variables, so I will move that 7x to the other side. So I'm going to subtract 7x to both sides. I'm also going to, in that same step, I'm going to go ahead and I'm going to subtract that 35 from both sides in the same step. So I'm going to subtract that 35 and subtract that 35. That's going to end up giving me 3x is going to be less than or equal to a negative 12. Notice I am dividing by 3, but it's not a negative. I don't care if 12 is negative. I am not the one dividing or multiplying by negative, so my sign will not change. I will divide both sides by a positive 3, so if x is less than or equal to a negative 4. That is my set notation. I just have to go, okay, x needs to be less than or equal to negative 4, so I'm looking for numbers that are really small. So that means I'm going to go from negative infinity. Infinity I always use as a parenthesis. We're going all the way up till we get to negative 4, and we're going to go ahead and throw a bracket on there for our equal sign. Okay, the graph of this is just going to look like, we'll go find negative 4. I'll put a circle on there. Now, x is less than that, so less would be that direction. All right, these are two just kind of special cases. When solving these, I'm just going to go through them quickly because I assume you can actually solve these. I'm going to end up having negative 8x minus 2 is greater than or equal to negative 8x minus 2. We're going to notice that this is either a true or a false statement because both things are the exact same. If you don't realize that, we can always add 8x to both sides and we come up with negative 2 is bigger than or equal to 2. So once again, these need to either be true or false statements. This is a true statement. And what makes it true is the equal sign right here. It says that negative 2 has to be greater than or equal to negative 2. Well, I'm going to choose the equal to option. That means negative 2 is equal to negative 2. That is a true statement. That will be all real numbers, which for interval notation, we go negative infinity to infinity, and we'd have both our answers right there. Now, if I was to graph this, the nice thing about not having to shade in heavily is I can just put a line right above this and say, yep, that's all my solutions right there. Now let's juxtapose that to our next one. Our next one will be another special case. When I distribute and simplify, first of all, let's distribute. So we'll have 40 minus 16x. That will be greater than negative 10x plus 40 minus 6x. Keep reducing. I'm going to have 40 minus 16x is greater than negative 16x plus 40. We're going to notice that both of these sides are the same. And we could reduce a little bit further. I could add 16 to both sides, give me 40 is greater than 40. Now, once again, if you have the same thing on both sides, whether you noticed it here or whether you noticed it here, your question is it true or is it false? Well, if we look at number 10, it was true because of that equal sign. Negative 2 does equal negative 2. But if we look at this one, it says that 40 is bigger than 40. 40 is not bigger than 40. This is a false statement. 40 is not bigger than 40. You have to have that equal to sign in order to have those all real solutions. So since this is false, we simply have to put there's no solution. You could write that, or you can just put no solution. You can't write an interval notation because it doesn't exist. There's nothing happening on the number line, so I won't draw anything on there. We just need to put false. It does not exist, or you can put that circle with a line through it saying it's the empty set, that it contains no solutions. All right, so that's how we deal with it if it's just a normal kind of linear inequality. Where it steps up a bit is when we have absolute values, because we know absolute values create two different situations for us. Now, notice our steps look the exact same thing as if I'm solving absolute values. It also looks the same way as if I was doing a square root. We isolate what's happening, we create our two cases, and then we solve both cases. So that the key word to all of these are isolate the absolute value. And that's where I bring up square roots. You're supposed to isolate the square root before you solve it. We always isolate these things before we do any work with it. So our first step is isolate it. So we look at number 12, it's already isolated. We have absolute value alone on the left-hand side, and we have a greater than, and we have a 15 there. Now, here's where absolute values get a little tricky. So we know that the first equation is going to look exactly like this, but without absolute value bars. So I'm going to have 5 minus 10a is greater than 15. Now, the next equation we need to write it with a negative 15. So we do need our 5 minus 10a, and we need our negative 15. Those are our two cases. Now, the weird thing about absolute values is if you look at that negative 15, we're actually checking the other direction of our absolute value. We're pushing it to that negative value. So think of this as being basically dividing by a negative, or the same idea, in that where if I have a greater than to start off with, to write our other equation, we must flip it to turn it into a less than. So when we're writing our new equation, we need to flip our sign, just like if we were dividing or multiplying by a negative number. And then we just got to solve these two linear inequalities, and we got to figure out what pans out later on. So let's go ahead and let's reduce these. So we'll first subtract 5 from both sides, giving me a negative 10. Let's change our color back to black. Negative 10a needs to be bigger than 10, noting we are dividing by a negative. I will write that most of the time, that we are dividing by a negative. That's a big deal because we need to switch our sign. Our sign now becomes a is less than negative 1. I divided by negative, so we need to switch that sign. That sign needs to flip. All right, so we have a is less than -1. That's one of our compound inequalities, so we are creating a compound inequality. For our next one, we're going to go ahead and subtract 5 from both sides, giving me -10a is less than a -20. Dividing by a negative means I'm going to flip my sign, so I'm going to have a is bigger than 2. So we have two statements. We have a needs to be less than -1 and a needs to be bigger than 2. Let's go ahead and graph these first before I write my interval notation. So we already have our set notation, but let's do our interval notation right here. So we have a is less than -1. Well, if a is less than -1, we're going to put an open dot at -1, and we're going to draw in that direction. Now, we'll have a is bigger than 2. A is bigger than 2. We don't have an equal sign again, so we'll have an open dot again, and we'll go in this direction. Now, we'll notice we do have a compound inequality that goes in opposite directions. Opposite directions means we're going to use the word or. A is less than -1, or a is bigger than 2. So when we're writing our inequality, we need to write -infinity to -1, and we have to do our or statement, but that's actually a union statement where we're using interval notation, and that'll be from 2 to infinity. I should put a parenthesis on that parenthesis, and there we go. We got our answer right there. That turns into an or statement. Let's do that one more time. So we have -2 minus 8x is greater than or equal to 30. The first thing we do is isolate. It already is. So we'll have -2 minus 8x. We write it as is to start off with, so greater than or equal to 30. Then we have to do it with the -30. But remember, when we write it as the negative version of it, of -2 minus 8x, we're going to flip the sign. Just like I was dividing or multiplying by a negative, I'm creating a negative, so I'm going to flip that sign. Now we're going to do some work on this. So I'll have -8 is greater than or equal to 32. Divide both sides by a negative. Notice a pattern. We're trying to throw a lot of those at you. We're going to divide by a -8, which means I have x is less than or equal to a -4. So I did flip that sign. On the other side, we are going to have our -8x is less than or equal to a -28. Divide by a negative means I'm going to flip my sign. So I'm going to have x is bigger than or equal to, I'll have -28 divided by 8, which should reduce to 7/2. Since I am going to be graphing this, I think it's a good idea to just plug that in your calculator or just look at it and know it's 3.5, just so you have an idea where you're going to put it on the number line. Now, I am also going to notice that we do have equal signs. So the first one says we need x is less than or equal to -4. So I'm going to put a closed dot at 4. I'm going to put an arrow saying it's all those numbers less than -4. And it says an x needs to be bigger than or equal to 3.5. So let's find 3.5. Maybe that's about here. And it wants all the numbers bigger, so we draw that direction. Now we're going in opposite direction once again. So we do know that this is an or statement, that x needs to be less than or equal to 4, or it has to be bigger than 3.5. Which means our interval notation is going to look like this. I have -infinity until it gets to -4 with a bracket, because we do have the equal sign. We're going to union that with that 7/2, and that goes to infinity. Those are both my interval notation and my set notation all at once. All right, now we're going to get to a different case. So I do want to notice what signs were given to me in 12 and 13. I have an absolute value is bigger than in 12. In 13, I have an absolute value is bigger than. Let's keep that in mind when we look at number 14. Well, first of all, 14 is not isolated, so I do need to move that 4 to the other side, which is going to give me absolute value of x minus 3 has to be less than or equal to a +4. Now, the fact that we switched our sign actually makes a difference. If we have an absolute, so let's look at 12 and 13, we had a greater than. So in other words, we have kind of, let's go, x, absolute value of x is bigger than some number. We know that this turned into an or statement. An or statement or a union statement. So it's or we used a union symbol. Well, something different is going to happen when we have a less than symbol. And let's see what happens there. So realistically, you can kind of see where we're going. We either have or statements or we have and statements. Or statements where we go in opposite direction, and statements where we kind of meet in the middle. So these are going to become and statements. But if we forget that, we can check it along the way. So we're still going to follow the same things. Isolate it, create our two equations. So I'm going to have x minus 3 needs to be less than or equal to 4. And our other statement is going to be x minus 3. Don't forget to flip the sign when we put our negative 4. Now we're going to go ahead and solve these. It just takes adding 3 to both sides. X has to be less than or equal to 7. And we're also going to have x is greater than or equal to a negative 1. Now, if I was to plot these, and x needs to be less than 7, less than or equal to 7, I would say, we're going to put a closed dot here, and it kind of looks like we draw an arrow over here. But if we look at the other statement, it says x has to be bigger than or equal to negative 1. Well, now we're on the same line. Maybe I'll change my color. We're on that same line, but we're going the opposite direction. Well, it can't be all solutions. So what this actually turns into is we erase the stuff that isn't kind of an overlap. So this tells us that x needs to be less than or equal to 7, and it has to be x is greater than or equal to negative 1. This is known as an and statement. X has to be between 7 and negative 1. X needs to be less than or equal to 7, and it has to be bigger than or equal to negative 1. So if you picture, let's say 9. 9 is bigger than or equal to negative 1, but it's not less than or equal to 7. That's where that and comes in. And restricts all of your statements to it has to be between these two numbers. So if we have a less than symbol, so if we do the same thing, absolute value of x is less than some number, we're going to have an and statement. An and statement, when we write it as an interval notation, is actually rather easy because we have to know our smallest number is negative 1, going all the way to 7, and then you're done. Negative 1 to 7, that is our and statement in interval notation. All right, let's do it one more time. I am going to note, based upon what we just covered, if it's greater than, we have an or statement. If it's less than, it's an and statement. So we should know that this is going to be an or statement just starting off. So it should go in opposite directions. Well, let's isolate first. That means divide by 8. And so we're going to have 3 minus 3x is greater than 120 divided by 8 is 15. Creating our two equations, we're going to create one that looks identical to it, minus the absolute value bars. And then we're going to have one where we create a 3 minus 3x. We're going to create that negative 15. Knowing to create that negative 15, I do need to switch my signs. Reducing this down, I would subtract 3 on both sides, and lo and behold, I am going to be dividing by a negative, so we're getting lots of practice with that. Dividing by a negative means flip your sign, so we're going to have x is less than negative 4. On the other end, we're going to subtract 3 on both sides, giving me negative 3x is less than a negative 18. We are dividing by a negative 3 again. We're going to flip our sign, creating x is bigger than 6. Now, I already know this is an or statement, but it always helps to, you don't have to memorize it. You don't have to memorize it. You just got to go down on the graph and see what it looks like. So x is less than negative 4. So if we look at our arrow going this way, I go x is bigger than 6. X is bigger than 6. There is no overlap, so this must be an or statement. Or statements are going to look like, that looks like a negative 8. We'll have negative infinity going to negative 4 with parentheses. We're going to union that with 6 to infinity. And that is how we deal with inequalities when we're doing absolute values. All right, guys, I hope you understood it. Let me know in class or email me if you have any questions on anything we covered today. All right, good luck.